for problem number 1 for our Chapter 9 review, we're given this problem. And this is a really easy one to do. Basically, you're just going to use Pythagorean theorem. Remember that when we choose our A, B, C, that C is always across from the 90-degree angle. And then the rest is arbitrary. Arbitrary is a big fancy math word that basically says random. So in other words, I can randomly choose this to be A, or I could randomly choose this to be A. It doesn't really matter. Anyways, this is the Pythagorean theorem, so it's going to be A squared plus B squared equals C squared, where A equals 6, B equals 18, and C equals X. So now I'm going to plug that in. 6 squared plus 18 squared plus X squared. 6 squared is 36. 18 squared, that's kind of a big number, so I'll say 18 squared. 324 plus 324, and this is still X squared. Let's add that together, plus 36. So all this equals 360 when you add that up. Now from here, I'm going to need to take the square root of both sides to get X by itself. So over here I get X. Now for this, the square root of 360, I'm going to do this thing where I think of all the perfect squares. In other words, I need to simplify this radical. So I'm going to think 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, 5 squared equals 25, 6 squared equals 36. And I'm going to stop there. I noticed that 36 goes into 360 10 times. In other words, I could think of this as the square root of 36 times the square root of 10. Now where I get that from is that 36 times 10 equals 360. Now the reason I listed the perfect squares is because if I find a perfect square that goes into this, then I can pull a perfect square out and then I can take the square root. So the square root of 36 is just 6 times the square root of 10. Now 10, none of these numbers go into 10 evenly, so this would be our final answer. The simplified radical of the square root of 360 is equal to 6 root 10.